Hi everyone, thanks for joining us today.
It does sound sophisticated.
Sophisticated, yeah.
With the ACE community for 3 years now.
Actually outlined everything.
Something that we find in the society.
First, talk about the problems that you're trying to solve.
Hi everyone, thanks for joining us today for another episode of Deep Random Talks. We have with us today Chris and Carla. Carla is my co-host, as you know by now. We're going to talk about a lot of interesting ideas in decentralized science and what Chris's company is doing in that space. But before that, Carla, what's new with you?
Yeah, so what's new with me? I guess my location. So last week I was in San Francisco and now I am in Schlangen, Germany, which is, I guess, the biggest change you can do, like going from San Francisco, tech hub, big city life, and then go to this tiny town in Germany, which is where I'm from, which is why I'm here. It's great to be here, but it's just such a switch.
Awesome. How about you, Chris? Tell us a bit about yourself and what are you up to these days?
So great to be here. First of all, thank you for proposing this, for inviting me. What we're up to? Well, we're busy building DeSci, so infrastructure for open access, and there's a lot of things to do. So we are constantly working. We are in a sprint mode, preparing for the next release. So that's what we're doing. I'm in my office in Switzerland, close to Zurich. That's where I am, and that's what I'm doing right now.
That sounds great. Thank you so much for introducing yourself quickly. What are you all drinking? I'm having some peppermint tea cold brewed. How about you?
A cafe latte from a very successful Swiss company that has completely cornered the market with cafe lattes. So, and they're very good. So that's why.
They're actually good.
Oh, is that
Very
right?
good.
Is there anything special about it, or it's just generally good?
I think generally the Swiss people have a long tradition of collecting milk with their cows, right? So there's a very large amount of pastures and cows and milk producing facilities. So hopefully this is where they can really bring out the quality. Making some better milk infused products. So yeah.
Wait, Chris,
really
do you
good.
think there's actual milk in those cafes? I feel like.
Yes, there is.
Oh yeah,
It's
all right, okay.
not like the American ones.
All right, okay. Well, yeah. So I'm just drinking water because I'm at my parents' house and they didn't have any fancy drinks. So I guess that's small town Germany for you.
I mean, water is all you need anyway.
German austerity right here.
Yeah.
Awesome. So, Chris, you said open access. Let's start there. So, you're talking about open access to publications and things like that, I assume. But let's go a little further back. So, what was happening in your world before you started working on this project? And, probably lead us to how this project has started to begin with.
Sure. So during the height of the COVID epidemic, I had two options to go on vacation and escape the madness. I could go to Dubai or Tulum in Mexico, and I chose the more adventuring one. So I went to Mexico, to this peninsula, and there I was standing on a rooftop terrace, having a fantastic time, listening to great music, having a good drink, and I met who would become my future co-founder, Philip. And so we sat down that day. There was a beautiful sunset in the background. It was a truly magical moment. And he sat next to me and we started having a informal conversation. And he was like, oh, yeah, I'm a scientist. Oh, you're a scientist. Oh, this and that. And we had these things in common that started to appear. And I quickly realized, actually, he worked, with collaborators I knew at my institute. And they had this. So we shared some sort of common social network. And we both started railing about problems in reproducibility and replicability in science, right? So we clicked on that, and it became very apparent. We spent the whole evening talking about the replication crisis, about the problems of reproducibility, about the incentive problems in science, about moonshots where we could reorder, improve things, and so it started really. We dove deep down into this rabbit hole of reproducibility and replicability, and we haven't stopped since. And also during that time, Yeah, I just wanted to add. So this was like the first little important meeting, and the second one is, we managed to meet Sina, who became our CTO, who's a absolutely incredibly talented coder. He speaks computer, and we've all coded, but he just being next to him, it was so impressive just to see his mastery. And so we had that energy, the three of us, right? We could see things. We had like domain expertise. I had, a way to connect these things. We had, a great software engineering view to like think of architectures. So we had that great energy, and it just happened. And we were asking ourselves, well, maybe we should take this a step further, right? And so we started thinking about it all very seriously and keeping in touch, chatting with each other, continuing into that common mind space to build, this. Essentially, we were, navigating the idea maze as like a casual adventuring party, in a way. So, and at some point we were like, wow, we're really potentially onto something. And so we decided to get together, make a company, and just start building it.
All right, cool. Yeah, well, before we get into the company and the solutions that you're building, let's maybe first talk about the problems that you're trying to solve. So you mentioned the replication crisis, which is a big problem for sure, but let's maybe talk about it. What does it mean? Why is it there? And yeah, why haven't we fixed it yet?
Yeah, sure. So it's so for those that don't know, essentially a replication is when you take you're repeating the methods in a published study. You're gathering new data, and you're rerunning the analysis on this new data. And your goal there is to see, well, if it replicates, you're going to have effect sizes. You're going to have statistical indicators within a range that says, well, there's really something here, right? And if it doesn't, then you're gonna have a discordance with that new replication study that usually has a higher sample size that allows you to do more precise inference and says, you know what, that was probably a false positive, right? You can think about that. You can think about it this way. So that's the issue. That is essentially the process of independent scientific validation, which should be the gold standard when it comes to validating scientific findings. It should be the absolute gold standards. And it's not something that is incentivized at all by the current system, right? So it's very hard to publish a replication study. It's not something that is considered sexy by high impact journals, which would then get you more grants, which will, allow you to grow your lab in your career as a scientist. So as a result, of there's a plethora of factors involved, but you could think that scientists are constantly exposed to bad incentives. And these bad incentives necessitate that they operate in the system in a certain way. And the way they're operating in the system tends to create fragile results, right, in various fields where these results actually do not stand the test of time. And there's many factors involved into this, right? But it's an absolute tragic state. So entire branches of knowledge have come crumbling down as house of cards as a result of the replication crisis. And for many young scientists, that when I started into science, this just became a thing. We had like the first replication whistleblowers in psychology, and then we had it in medicine, and so we started having these hotspots of communities coming together with tremendous momentum and saying, wait, let's really make sure we have this right. And so they started replicating these big, impactful, super novel studies that were making grandiose claims, right? Especially about unintuitive findings, right? It's the type of study that gets the attention of journal, right? Because it's like, as a journal, you think, well, that's going to generate audience, right? That's going to generate demand for my paper, right? And so that essentially, those types of incentives have fragilized, right, the quality of the knowledge produced by scientists. And there's even some great meta scientists like John Ioannidis who say, well, this, why most research findings are false, right? And that is one of a very famous paper he wrote explaining, the structural forces at play here that make it that we have to be extremely skeptical about published results, especially when these results seem novel and surprising and based on, a certain statistical method or certain approaches, because they're very fragile. And I think, you could say, well, this was psychology. Well, actually, it really kills people. So in medicine, there is a raging replication crisis, right? If you look at early cancer marker drug targets, there was Amgen, who a couple of years ago, this big replication effort on 50 plus papers published in the top journals of biomedicine, right? So this is Nature, this is Cell, this is Science, this is like the Lancet, the New England Journal of Medicine, right? So the Journal of Immunology, right? So these are like the extremely high and prestigious avenues, and they couldn't replicate. They were able to replicate about 10% of the published findings. Right? So let this sink in for a moment. That's insane. And that's only the tip of the iceberg. We've never done, as a society, we've never said, hey, let's put the brake, let's do randomized selection of studies and try to calculate the empirical replication rate of our literature in specific fields, right? We haven't done that. We've done, efforts in some directions, to gather some important findings. But there's this immense sense of unease among scientists also, right? So this is not something that's only affecting the public. It's really scientists feel very uneasy about it, and it's something that is of urgent priority to improve and to be fixed. And again, there's no simple solution, right? Because it's a multifaceted problem that has to do with the misalignment of incentives in the lives of scientists.
Yeah, that makes a lot of sense. And I didn't know about the 10% medicine. That's crazy. But yeah, so you were mentioning journals quite a bit here. And I understand that the incentive structures with journals providing prestige to scientists. So scientists want to get into the journal so that they have to produce something that the journal wants to publish. Makes sense. Kind of one of the big reasons why we have the replication crisis. But one of the other issues that I personally have with journals, for sure, is the problem with open access. So I was doing research for my thesis, and I had university level access and everything. And even though like my university pays millions to these journals and their publishers, I still don't have access to all the knowledge that I need to be creating my research. And that's really one of the big issues that I have with the current state of science. So yeah, maybe tell me, because you were saying you were doing science before. What was your experience publishing in journals? What was it like trying to get an open access paper out? Did you even try that? Was it important to you? And yeah, what's the problem here?
Yeah, great question. So, it's a definite problem. I've had my experience as a scientist when I was publishing papers was I've had great experience with talented scientific editors, right? Great editors. I had also very good peer reviewers, right? Which a lot of people, can't really say that. I mean, there's with the exception of reviewer 2. If you're listening to me, reviewer 2, we'll have another discussion. But overall, I've had a great experience when it comes to like the process and the handling. I've had terrible bad experience with the tech behind it, but the human factor was always excellent, right? Overall, it's been excellent. Not always. Overall, it's been excellent. The problem I have is with the business model of these scientific publishers, right? Because these corporations, they have profit margins that are higher than the pharmaceutical industry, like Pfizer, and Apple, and Google. So think about that. So Elsevier and these groups, they have profit margins that are higher. What does this tell you? It tells you, there's a monopoly situation, because historically these profit margins would tend to shift to go down over time as a result of fair and free competition, which has not happened, right? So we have a distorted market, which has a monopoly situation, which is extracting immense rent on libraries and scientists and funders, right? And so that's the rent-seeking behavior of these established giants of publishing, which have consolidated into an oligopoly, which has become extremely extractive. Because when you think about it, editors most often work for free. Peer reviewers work for free. Scientists give their work for free. And the journal will then either take your work, do according to peer review, do the formatting, and then sell it as part of like a vast bundle deal at an exorbitant price to libraries, which have no choice but to pay, because access to the state of the art in science is an essential requirement for their faculty and their students. There's no way around it. You can't say, well, guys, we're not subscribing to the Cell line of journals. We'll do other things, No, that's never going to fly. The whole biomedical department will be like, wait, what? I can't work. Literally, that's where it leads, right? So that's a monopoly situation, right? Because of the copyright and the subscription models. So they have these libraries are forced, right? The prices keep increasing over time, right? Because they have that monopoly on knowledge. So that's one thought that's really broken. And then there's this new model that came up, which is the APC, author publishing cost. That's the idea. You want to publish in open access? Well, you pay us, and we'll do the formatting, we'll do the coordinating, the peer review, we'll do the certification, the dissemination, all those things. To be fair, journals play an extremely important role, right? Especially in the certification process. So it's very important not to take my commentary as saying journals are bad. It's not the case. Journals are an absolute necessity in our world of information, right? We need to have filtering devices. But the business models that are used by them have become extremely extractive over time, right? And open access, for example, I had a paper in Nature Neuroscience before it was an open access publication, before it had the option, before it became a hybrid journal, which gives you the choice to publish in open access or publish in closed access, right? Published in closed access, at the time, I only had that option. I still had to pay $2,000 for color figures. I had color figures, right? And this was like, 6 years ago. Well, color figures is an extra fee, $2,000. Everyone's on digital now, right? It's completely ridiculous. And the other side is like nowadays they have an open access option, but the cost of publishing is, just shy of 10,000 euros, right? It's 9,000 euros or something like that, right? It used to be, $11,800. Now that the exchange rates have changed, it's different, right? But essentially it is an exorbitant price to pay for the service, and the reason for that is that these institutions have been very successful at capturing the prestige, right? And what is prestige? Prestige is essentially, the eyes of funders, right? And how do you attract the eyes of funders? Well, you create a social consensus about the excellence of a journal. And how do you support that social consensus about the excellence of a journal? Well, you need metrics. Well, what is the metric that is driving the entirety of the scientific publishing industry? It's the impact factor. So every journal is linked to a certain impact factor. And as a scientist, you shop for impact factor. You look at journal, you rank order them by impact factor, and you're like thinking, this could go up here. It's going to be a tough battle, but I could do it, right? Or maybe, well, I'm not, I don't want to get rejected too often, so I'll just go for the middle, So there's that little strategic aspect as a scientist. You're really trying to get maximum impact, right, for your work. And the same goes, for other branches of science that are organized around prestigious conferences like computer science, right? So there's that impact, which is the primary KPI and the primary driving force. And what does it represent? Well, impact factor is the average number of citation accrued over X years. That is that these papers tend to accrue in these journals, right? So it's a hard metric. Of course, there's a lot of problems with that, right? There's problems about, looking across fields with different cultures. There's more refined methods of calculating impact, but essentially it's a measure of the scholarly attention economy, right? So when an editor takes work in as part of his job, they are essentially curating a portfolio of potentially high impact work, right? So they're acting. So an editor, an editor-in-chief at an important journal has this important responsibility to keep the content at the highest standard possible, understand as something which will generate an impact to its constituency, to its readers, right? So they have this is, one of the things they have to really optimize for. Now, you need rigor as well, right? So it's not just about impact. So you do have, this is why the peer review process in the journal is very strict. But very often what happens is they tend to be conflated. It's like they conflate that reviewers are judging you on impact, but they're also on the soundness of your method, right? So this is for something that's quite frustrating for authors, like, oh, this is not novel enough. I just read the abstract. Like, just forget it. It shouldn't be in the New England Journal of Medicine, right? We've known this for 5 years. I'll bite in a bit of a different way. And by the way, you should cite X. And so you have these kind of like frustrating, reviewer experience because they're curating on behalf of the editor, telling the editor cues about how impactful they consider that work. Then you have the other types of peer reviewers who are like, they're like, this actually would have, the type of reach it needs to have, but let's go deep into the details and look at the quality of the method and whether or not the conclusions are supported by the data. And generally, they will go in and give you very thoughtful criticism and constructive ideas for how to improve your work, in that context, right? So this is essentially how the system works, right? You could think about it that there's a scientometric machine. At the very top, there's Clarivate, Analytics, and Elsevier Scopus, which are calculating, Clarivate and Thomson Reuters calculating the impact factor, distributing this to journals. Scopus is competing with Clarivate on impact metrics and trying to index more journal. The incentives flow from these entities downstream to publishers and owners of scientific journals, right? And then scientists will shop for journals at certain different levels of impact, right? So that's how the system, more or less functions, right? In its, current misaligned equilibrium, right, in a way.
I love that you brought up the business model as one of the main problems. A lot of us who have worked in academia, we always have this very pure view of what science is and the things we are doing. And I've talked to so many people that look at people who leave academia and go to industry as impurists and all of those things, right? What I love about what journals have achieved to create this whole, misaligned ecosystem of incentives is that they're really playing with the ability of people to reimagine what their self worth is and what their value is in this whole ecosystem. When the value of you as a person, as a professional, becomes the number of papers you have and where you have published them and the corresponding H index and whatever, of course we end up in a system that we currently have. So, and the very first time that I got, I had a bit of a dose of reality was when I was reading the book Sapiens. I don't know if you've read it, but it talks about how science throughout the history always has been funded by powerful people. All of the expeditions that found the New World and all of those, of course, a king somewhere was like, here's a bunch of money, go figure these things out because then we will have more lands or whatever. So, and that's exactly the same thing that is happening now. Pharma is coming in, funding a lot of research in medicine, and then journals are more incentivized to publish those sort of things because not, maliciously even, but the system is set up for it to be so, even I go as far as saying it is corrupt because, we are not really measuring things properly. So it's very interesting. And I think a big component of this is the fact that the system has many, many, many single points of failure, other than the fact that the whole incentive system is set up incorrectly, but also, two grad students sitting in two different labs as your reviewers number one and reviewer number two are pretty much judging if you can get into this journal or not, on top of however good the editor is. So it's interesting to see what other business models could potentially exist that doesn't have this problem.
Yeah. No, absolutely. And I think this is probably one of the most pressing concerns we have, right? And it's like, it's not just business models, right? I think this is just a subpart of it. It's also the scope of scientific validation and the hierarchy of scientific validation, right? What do we consider most valuable? How can we create better systemic incentives to improve the replication rates? And I think this is probably the most fundamental part about this whole journey, is to have a more holistic evaluation system. And you do have, so one of the reasons I think, a lot of journals have not reinvested in improving the essentially, verifying for reproducibility and things like this, right? The reason is obvious, because these are the types of investment that do not give them a competitive business edge, right? It's not attracting more authors, to the contrary, right? So it is actually against their business interest. There's essentially, this is a case of stakeholder misalignment, right? Because the journal as a company has a fiduciary duty to a shareholder to maximize the return on investment of their shareholders, right? And that is enshrined by law. And you start seeing different behaviors when you look at different stakeholder communities, right? When it comes to that, if you take, for example, the American Economic Association, which is, you could say, it's the high priesthood of economics, right? It is the highest level, the most important publisher of top journals in economics that are extremely rigorous and strict, right? And one of their journals, the flagship journal, is the American Economic Review. Like, getting an article published in the American Economic Review is a multi-year journey, right? It is an absolutely spectacular achievement because it is so difficult. And they're very rigorous articles. And the editor, the data editor of the American Economic Review, has a team of undergrads and graduate students that verify reproducibility for each of the papers they publish. So they go out there asking the authors for the code, the data, linking everything together, verifying that it reproduces. And so they're having like an insanely high bar for rigor. And it's incredibly impressive, but it's not a sustainable business model for them. So they're doing what is right, but they're not, having a sustainable plan into the future, right, about it. And there's a lot of like difficulties around that. So, I mean, it's incredibly admirable that they do this, right? And I think it also comes to speak to what it means to be published in a journal, right? It means something very, very different if someone has actually verified the reproducibility of your results from A to Z compared to a journal that hasn't. Right. So this is like a completely different ballpark of services. Right. Let's just be honest, completely different ballpark. And these things are implicit. We don't know that. Right. There's nothing that says on the American Journal of Economic, well, it's proof of reproducibility. Right. We don't have this understanding of what it means beyond it's published in a top journal. Right. So, making those attributes of research explicit is, we believe, an important first step, is to allow these authors to say, hey, I've gone beyond the call of duty. My data is fair. It conforms to the FAIR principle. My results are reproducible. Here, you have the proof. You have an executable notebook. You have a system to reproduce these results, an interface, right? You can essentially verify the research object and give these markers, these attribute of work to these research objects, right? And now we start unbundling what it means to be a journal. We're unbundling it, and we start creating these distinct and discrete attributes that give you incredibly valuable information about the research that's published. Imagine you're a funder, you're the Wellcome Trust. You have a funding mandate. Verifying the enforcement and the conformance to this funding mandate is very difficult, right? They have to do these randomized audits. They have to, checklists, all these things. What if they had a badge, an attribute that says, approved by Wellcome Trust, right? It's like a funding mandate respected, right? What if these funders had the ability to define their own attributes, right? That drives their value chain. And so that is the concept of like unbundling, these markers of these functions that have been performed by scientific journals. And in this process of unbundling it, we can create systems to return value to scientific communities that actually produce the work, such that when you pay for an APC cost, right now it's like $5,000. Well, the money goes to the people that are actually doing the work, right? And very often these are, graduate students that are working, under a PI. There's like these, teams of reviewers that might form. There could be different structures, but essentially we could create systems to supplement the precarious wages that scientists are faced with today. And so that's the idea behind returning that value. I'm not saying all of this should be free, right? The idea that labor should be free, I believe, is a very wrong-headed idea. You could say, well, it's part of my job as a scientist to do this. Well, then the question is, well, how much of your job exactly is it part of, right? Is it 10% of your job, 1% of your job, 50% of your job? And then everyone contributes to different levels. And now you have free riding happening, right? People don't review, they're like just waiting for their colleagues to review. So you have all sorts of systems that start creating these selection mechanisms, right? And that are unfair to these scientific, to these poor, overworked, graduate students and postdocs and people in these precarious academic positions, that they should be giving, 6 hours of their time doing in-depth peer review analysis for what? For a thank you from the editor, That, and this is so that this whole system, and then that work is being sold for profit, right? Or their funders being charged, $5,000, for Nature Communications, or publishing in one of these other prestigious open access journals. So there is a real problem around that, and we need to fix it.
Right. Okay. So we need to fix it. I mean, you've been mentioning some solutions like badges and then returning value to the scientists and the reviewers. So let's maybe start from the top, or from the very beginning. Like, how are you and DeSci Labs thinking about solving these problems? So we had open access as a problem. We have peer review. We have the reproducibility crisis. We have unfair rewards. Like, what's the base level? Like, how do we start building a new system of science that enables all of these problems to be solved? Like, what's the first step?
And that's a great question. The first step is well, very pragmatically speaking, is actually giving scientists a good user experience when using, scientific repositories and publication platforms, right? We should treat scientists with respect, and that we should not expose them to UIs that are from the 1990s and to all sorts of terrible processes to get your work uploaded and, passing all these checks. These processes are, fundamentally they stifle sharing of research artifacts, right? So we have to make the user experience better. We have to create a solution that can create a stakeholder alignment, right? That has that sets the right types of incentive, so that we can reward scientists that go beyond, right, the call of duty and actually do these self-reproducible research objects, right? And one of the things that we are particularly focused on as DeSci Lab is, hey, let's build a system where a scientist can, do more than publish his PDF, right? And a system that is a seamless experience, that is a generalist repository that allows you to have, your data, your code, maybe a video of a conference you gave, create these rich interconnected documents that essentially contain this history of that discovery, and preserve that in an open state repository where the links are consistent, where they're cryptographically secure, where link rot is not an issue anymore, right? So creating these time capsules of knowledge, essentially. And the second part is about making that a rewarding experience for scientists, right? So we need to have something better, something where you put your work on such a platform, you feel proud. You share it with your colleagues, and they tell you, wow, this is great, fantastic, I love it. I'm now making my work my pride, because it's important to understand, as a scientist, you spend years and years on a paper. And it's your pride, it's your work, it's your, it's a very important part of you. And right now we're not, honoring, I think, this new knowledge that's created to high standards the way we could. And so I think the first part, is, respecting scientists, giving them a great user experience. The second part is like making them proud of creating these research objects, so that when their colleagues, explore these interactive documents, they think, wow, this is fantastic. This is actually a step forward. So those are two essential agreements. And then, of course, the third is we can create explicit incentives, right? But I think, this is something we should really come in last, because I believe, the power, especially in the scientific community, of intrinsic motivation, of, doing things because it's good, provided they feel respected, provided their work is placed in a beautiful canvas that other people will appreciate, is something that will go a long way.
So you talked about a lot of high level ideas. Okay, so let's ground this. Let's say I'm a grad student. I've done a bunch of projects. I have data, I have model, I have code, I have a write up, a bunch of reports, whatever else I can imagine. So when you say objects, you're referring to these pieces? Like, can you give, like, okay, I come to your platform and I'm like, I want to be a published researcher on this platform. So walk me through the user experience. What happens there? So I have these things that described. What happens now?
Yeah, sure. You go on the app. You drag and drop your preprint, or typically a PDF, or you link a DOI, or you link from a preprint platform. We'll fetch that data. So now you have you have your manuscript. Then you copy paste your link to the GitHub repository that's linked to it. Copy paste the link to your data repositories. We pull all of this, right? Copy paste links to like a YouTube video. Just pull everything, right? So it's essentially an aggregator. It's like a giant black hole just pulling these objects in a very simple and intuitive user experience, right? And then you have all of these objects that are pulled and created in this version control immutable linked data structure that is versionable. Next thing you can do is you could say, hey, actually, I spend a lot of effort doing this Jupyter notebook that outputs results of my paper, and nobody ever uses these things, right? Because they're like on some GitHub repo, and like it's a pain to set up and everything, right? Now DeSci Notes gives me compute on my research object on top of it, right? So I can start executing my Jupyter notebook in browser, right? So you're here, you move from your experience where you're reading the manuscript to an experience where you're into a state-of-the-art VS Code environment, with the compute-enabled capabilities that allow you to replicate the results of that paper. So next, you're the undergrad. You're thinking, hey, I would love to be able to connect my figures and my results to my code, to my reproducible container. And you essentially just highlight segments of your paper and you link code. So you can link like a section of a Jupyter notebook. You can link like an executable file. And then you can click on that, right? This is done through annotations. And then you can essentially provide that interactive experience to a reader where he can just click and like start reproducing the results, right? Now, this is not new. Like there's other platforms that have done this in the past, right? I just want to stress this out. This is called reproducible research, reproducible documents. But what we're really focused on is making it easy for users to do it, right? So we want to like lower the barrier to entry as much as possible so that, an undergrad can actually get to a result that they feel proud and happy about, after, maybe like not too long, right? They should be able to do it efficiently, right? And the results must be satisfying of that. So that's just a way, how you're linking the front end, which is your paper, with your back end, which is a database, which is, your code repository, just like, Balaji says in his numerous interviews on this question of DeSci, right? It's linking front end with back end. And the power of this is we can link front end and back end and do it with an immutable data structure that doesn't break. So we have 100% consistency with all the connections. So think about those as, hyperlinks without 404s, right?
Yeah, I love what you said right in the beginning. And now with your description of the platform, it makes so much sense. Like you said, it's a black hole that pulls all the information. And actually, it's also kind of similar to a black hole where you can't or you don't want to escape because the gravitational force is so strong because you have everything right there. And if it's a great user experience, you don't want to leave the platform, which is not a bad thing like it would be with other like social media platforms where you can't ever leave, because it's so addicting. But no, it's a decentralized platform where there's not any extractive, malicious players there that just want to keep you on the platform. But no, the platform itself is just so good that you don't want to leave. Yeah.
So that's the next thing. So think about that. So if I'm seeing a system like this done by DeSci Labs, I'm going to think, oh, this is a SaaS company. They're going to charge me for every node I create. I'm going to be stuck in their ecosystem. There's going to be value capture all over the place. And I'm going to be sold on my data, my analytics. I get vendor lock-in, right? So that's the way to think about these things, right? In terms of when you're worried about questions of and you're when the company goes bankrupt, where's my data? What happens to it? So there's a million questions surrounding how you store scientific artifacts, right? And the thing that's powerful about this infrastructure is that we are linked to an open state repository. So it's not a silo. It's not like an Amazon database. It's not a silo. It is essentially an index that everyone can look at this information. You don't need to be using the DeSci, hosted platform that we're building to access that data. You can just listen on the events on the contract. And what if you get the identifier of that research object? Well, you can go into IPFS again, without any of our interventions and pull all the data. And you can also see how many stored copies of this data are out there. And so you can start you have an open database. Right? It's truly open access. If the company goes bankrupt and disappears the next day, well, this is not disappearing. It's still there. And someone else can pick it up. And so this is why we're thinking about open access as open state, right? This is the next frontier after open source is open state. And open state can be sustained if you have a network of these open access DeSci gateways, right? Operating around the world. That would be operated by libraries, or organizations or groups of interested people that start operating these gateways to knowledge that have this ability to distribute and to reinforce the storage and the connections between these objects, such that it every new gateway that's added actually improves marginally more than the previous one, the value of the network, right? So that's the thing. That's the main distinction between a closed state and an open state repository. And the next thing is, of course, these objects, right? These objects are completely under the control of their authors, right? So they sign with their cryptographic key the creation of these objects. And the only way to update and version control the canonical version of the research object is by having access to that private key. All right, so you need that private key in order. So these are digitally signed objects, and they're stored on an immutable record. It establishes a trace of provenance.
So basically now in this system, it's not journals that own the scientific record. It's actually the scientist who publishes their work that owns this record, or they're part of it, right?
Yeah, they have full control. Co-authors, contributors, people that are invited by the node creator has full control, and we cannot interfere with this.
This is quite interesting, Chris, and I'm very excited to see where your platform and ecosystem will go from here. Lots of interesting things to think about.
Okay, well, I mean, it's a wonderful conversation, Amir. Thank you for organizing.
Yeah, but what's the verdict for people who have listened to this conversation? You know, what is something that you want them to look up, to learn about?
Yeah, learn about the things they don't tell you. We keep getting told trust science, right? With a hammer.
That's great. How about you, Carla?
So my call to action here, if you're a scientist, maybe this week, next week, find one or two people you can like tell about your work and like make it understandable. Please lose the jargon and just tell somebody, what are you working on and what's surprising, what's cool about your field and why you're working on this. So that would be my call to action.
Awesome. I'm excited to see how platforms like, DeSci Lab is going to, bring the science a little more closer to, everyday people being able to touch them. Thank you so much for listening and watching this conversation. Please come back next week for another episode of Deep Random Talks. Hope to see you there. Thank you so much.